Dear students, today we'll see the third point in our first topic of basics of electronic circuits in ECD lab, in which we are going to see what are active components, and in that we are going to see what is a diode, what is Zener diode, and what is bipolar junction transistor, that is BJT. So let's start with the topic active components, and I have named it as part 1 because in part 1 I will be speaking on diode, Zener diode, and bipolar junction transistor, that is BJT. And in part 2 I will tell about MOSFET, SCR, DIAC, and TRIAC. Okay, so let's start with this. Now, before going into what are those active components, what are active components actually? First, we had studied what were electronic components, and then in that we saw there were two types of passive components and active components. And in passive components, we have seen that they do not deliver energy, they will either dissipate or consume or store energy. Okay, and in that we studied what was resistor, inductor, and capacitor. But now, what are these active components as compared to passive components? So here, if you see, first point I have given, active components deliver power or energy to the circuit. They can deliver power or energy to the circuit. So they are not consuming anything. They are not consuming, they are giving, they are delivering. Okay. Point number 2, they produce energy in the form of voltage or current. Okay, the energy whatever they are going to give will be in the form of voltage or current. Number 3, active components can control the flow of current. Obviously, when they are able to produce or generate, they can also control. Number 4, they are capable of providing power gain. Obviously, because if they are able to give voltage or energy, it is obviously giving you the power, because power is nothing but voltage into current. Okay, so that power gain also you can get. The next point says that active components are energy donor. Yes, they are giving energy. They are not dissipating or consuming energy. They are giving energy. And they require an external source for all these operations. So an external source is required for all these operations, but they are called as active components because they give energy or power. Okay, they produce an voltage or current. Clear? Then we'll go to see examples of active components, whatever we are going to see in this lab in point number 3 and 4. So in point number 3, we will be seeing diode, Zener diode, BJT. BJT is bipolar junction transistor. Then in point number 4, you will be seeing MOSFET, that is metal oxide semiconductor field effect transistor. Then you will see SCR, that is silicon controlled rectifier. Then you will see DIAC and TRIAC. Now, at this stage, when we are studying unit 1, at this stage, you should only know what is the function of these components, what are the symbols of these components, what are the types of packages you can get, and what are the applications of these components. A detailed study of this we will study when we go to the next unit, when we study your semiconductor devices. In that study, basics of semiconductor devices, in that study we will go to basically form a diode and how it will behave, what is forward bias, what is reverse bias, all that we are going to see at that time. But at present, at this stage, you should know what are these components, what are the symbols, what are the packages available, and what are the applications. Okay, so let's start with the first, diode. A semiconductor diode is a two-terminal electronic component with a p-n junction. This is also called as rectifier. Okay. Now what will happen is, when we study semiconductor devices, we will study something called as p-type material, p-type material, and we will also study something called as n-type material, p and n type of material. When you connect p and n type of material, there will be a junction here. There will be a junction produced. How that junction is produced? what is that potential, what is barrier potential, that everything detailed study will study once you know basically what is p and n type of metal. But at this stage, you just know that semiconductor diode is a p-n junction, and it will be having two terminals. This is one terminal, this is another terminal. This is called as anode, and it is marked as A. This is called as cathode, and it is marked as K. And if you want to see the symbol will look like this. You will be having an arrow mark and a bar. Okay, so this will be your anode, and this will be your cathode. Okay, so this is how its structure is, and this is how the symbol is. The first one, whatever we have shown, is the structure, and second, whatever we have shown is the symbol. So at present, you remember the symbol. Symbol is very important. Okay, so it is a semiconductor diode, a two-terminal electronic component, active device, which is a PN junction. It is also called as rectifier. It is also called as rectifier because if you give the input any alternating quantity, say this is your alternating waveform in electrical. If you give this input AC, the output of diode will be a direct quantity DC. Okay, that is why it is acting as a rectifier. A rectifier is a process which will convert AC to DC. Okay, that is afterwards we'll see again. But at present, you just know that what is a diode and what is its symbol. Then here you can see I've shown the symbol. So you can see a big arrow here, this big arrow, and then here is a bar. So this is an arrow, and this is a bar. Okay, and the terminal which is connected to the arrow is called as anode, and the terminal which is connected to the bar is called as cathode. Okay, and the direction of arrow will give you the conventional current flow. Okay, now anode is always connected to positive terminal, and cathode is always connected to negative terminal. Okay, so this is how a symbol of a diode looks. This is what is important for you to know at this stage. Then how does it represent with an actual package? Okay, so here you can see an actual package of diode. So here you can see this strip, whatever is shown here. Wherever this strip is near to which terminal, that terminal will be taken as cathode. This will be taken as cathode. And opposite to that will be taken as anode. It will be taken as anode. So here you can see the symbol for the same. This is anode, and this is cathode. Okay, so this is how you can represent anode and cathode of a practical diode through its symbol. Then we will have a note on what are these anode and cathode. The anode, which is the positive terminal of a diode, is represented with A, and the cathode, which is negative terminal, is represented with K. To know the anode and cathode of a practical diode, the fine line is drawn on the diode, which means cathode, while the other end represents the anode. So the bar is representing your cathode, and the arrow is representing your anode in the symbol. Then what are the purpose? Why we are studying this diode, and what are its common thing, where it is used much commonly? Okay, now the feature of diode is it can allow current only in one direction. It can allow a current only in one direction. Means what? Say for example, this is your current waveform. Okay, if you pass this through a diode, then the output will be only when the input is positive, the diode will conduct. When the input is negative, it will not conduct. When the input is positive, it will conduct. When the input is negative, it will not conduct. So this input was alternating quantity, plus and minus, both were there. So it was called as alternating quantity. This is only plus, only unidirectional. Okay, only unidirectional. So it is unidirectional. It can be called as a direct current. Okay, so you are able to convert AC to DC because of the feature of the diode, where it can allow the current to flow in one direction only and block the other direction. Okay, and because of that, when it is allowing current to flow, it is acting as an on switch. When it is not allowing it is acting as an off switch. So it can be used as a switch also. So these are common things, common purposes why we use diode. Okay. So here you can see number one, a diode is used to allow the electric current flow in one direction, that is in forward direction, and to block in reverse direction. Okay, so we have seen only the plus half cycles at the output, minus half cycles are not given to get produced. This principle of diode makes it to work as a rectifier because you are converting alternating quantity into a direct quantity. Thus, the output will be DC, that is direct current, removing the AC components. Alternating components are removed. The circuits such as half wave rectifier, full wave rectifiers are made using these diodes. These are some important applications. Second point, a diode is also used as a switch. It helps a faster on and off for the output that should occur in a quick rate. So whenever the input is positive, it will conduct. Whenever the input is negative, it will not conduct. So that will be taken as forward bias and reverse bias when we study it in semiconductor or devices. That time you will understand it much better. But at present, you know that when the input is positive, it is on, and when the input is negative, it is off. That is, when anode is made more positive than cathode, it is on. When anode is made negative with respect to cathode, it is off. Okay, so it can act as a switch. Then to see the symbol, to see the structure, and to see the characteristics graph. Now here our characteristics graph at this stage is not so important because this again we are going to study in our semiconductor devices. So here you can see the first one is your structure where you have shown p-type material and n-type material, and you can see that it is conventional current flow, positive current flow, conventional current flow. It is not flow of electrons, it is flow of positive components. Okay, so with that same, you can show an arrow here. This arrow also will indicate the conventional current flow, and then a bar here. This will be your symbol, and this is how it can look practically. Practically, you can have a strip. That strip will be near the cathode, and then opposite to that will be your anode. Okay, and if you see this are characteristics. Okay, so initially when you give a positive voltage, when anode is made little positive with respect to cathode, and when it is able to cross the barrier potential, there will be a barrier potential which I will be explaining you in semiconductor devices. It will be 0.7 volt for silicon diode, and it will be 0.3 volt for germanium diode. So that voltage will be opposing your applied voltage. That voltage, if you cross initially, then you can see there is a current flowing. Okay, there is a current flowing. So here you can see a graph of current at the y-axis and voltage at the x-axis. Similarly, when you apply a reverse voltage, okay, then the reverse voltage will give you a leakage current for a longer time, and then after some time it goes into breakdown region where the current reverse will increase, and if it increases more, it can damage the diode also. Now this characteristics we will again study in our second unit when we study semiconductor or devices in detail. When you understand what are the flow of charges, what are electrons and holes, at that time you can understand this better. But at present you only know what is a structure, what is a symbol, and how it looks practically. Then you see the different packages in which you can get a diode. So here this will be the usual ones which you will be using in the lab. So here you can see the strip, and wherever you see the strip, that is cathode and this is anode. Even here you can see there is a strip, this is cathode and this is anode. Okay, so even here you can see, here you can see, here you can see, here you can see. Okay, and rest all are your improvised packages where you have the main two terminals as anode and cathode, and then other features are also there in that. You can have a rectifier also, as we have shown here. This can act as a rectifier. Okay, so here you can give your AC, and in these 2 points you can get your DC. So in that way you can have many different packages, but the simple one is this, the starting one what I've shown. Whenever you have a package like this, and if there is a strip here, okay, then that terminal which is near to the strip will be taken as cathode, and the terminal opposite to the strip will be taken as anode. Okay, so this will be a plus and this will be a minus. These 2 points These two terminals will be important in any package. Then we'll go to see what are the applications of a diode. Applications of a diode are rectifiers. It can be used as a rectifier. So here you can see that when the input is a alternative quantity like this, okay, the output will of a diode will be, as I've told you earlier, the output of a diode will be only positive half cycles. So that means alternating quantity or alternating current is converted into direct quantity or DC. Once you do this AC to DC, it is called as the rectification process. Rectification process. So it is acting, it can act as a rectifier. It can act as a switch because when the input is, when the anode is more positive with respect to cathode, it is allowing the current to flow. So it is on. When the anode is less positive with respect to cathode, okay, then it will not allow the current to flow, so it will be in a off position. Okay, then you can have another application like a clipper circuit. When the input is say like this, and if you want to clip any part of the input, say for example you don't want a part, you just want only so much at the output, okay, then you can do that by using a diode. You can have a clamping circuit where whenever the input is there, that inputs DC level. So here the DC level is 0 volt. So case at DC level can be increased to positive or negative. So if you increase to positive, you can have your waveform here. So here will be a 0 and this DC level you can increase. That is how you can use it in clamping circuits. You can use it in logic gates where you can use it for the digital electronics logic gates where you're going to study NOT gate, you're going to study AND gate, you're going to study OR gate. Now in the manufacturing of that, you can use diodes. That diodes are some of the basic elements which are used in making such gates. Then you can use it as voltage multipliers also. So here the last application, it can multiply voltage also. So these are a few applications of diode. Okay, there are many applications, but these are few what we have mentioned. Then we'll go to see what is a Zener diode. Now, Zener diode is also a semiconductor diode, but the difference here will be it is a heavily doped semiconductor diode. Now, this word heavily doped, you will understand once you know what is doping in semiconductor devices. We have to do doping, that is, we have to add impurity to a pure semiconductor. We have to add impurity to pure semiconductor so that it can improve its conduction. It can give or it can allow a current to flow. Movement of charges can become easy. There will be a large number of either electrons or holes what you can produce. Okay, that is where it is called as heavily doped. So even this Zener diode also will be a structure-wise p-type material and n-type material only. Only thing, the p and n type of material will be very heavily doped. Here you can have your anode and here you can have your cathode. Okay, and it will also allow the current to flow in one direction only, but Zener diode is specially operated in reverse direction. In reverse direction, this is very important. Its speciality is in reverse direction because if you see the graph in reverse direction, at one stage the voltage across it will remain constant and current will go on increasing. So if you are able to make a voltage constant and current varies in between, then you can use such type of device in an application called as voltage regulator very nicely. Okay. Then if you go to see the symbol and package of Zener diode, so here you can see the symbol is same like your semiconductor diode, that is PN junction diode, but only thing, this part is extra. It is a Z type of thing here. It is a Z type of thing. Then you have an arrow which will mark the conventional current. The terminal near the arrow is called anode. The terminal near this bar, which is Z type, is called as cathode. So only difference here is you can draw a simple diode symbol. Only thing, this becomes Z type. Okay. So similarly here, the package what you get if you are having a strip like this, near the strip, whatever terminal you are having is called as cathode, and opposite to the strip will be anode. This will be your package type. Okay, this will be package, and this will be your symbol of Zener diode. Okay. Then how does the Zener diode work in reverse bias? Why we say that it is very good to work in reverse bias? Okay, so here as a note, we can see this first. A Zener diode operates just like a normal diode when it is in forward bias. However, when it is connected in reverse bias means your anode is made negative with respect to cathode. Okay, whenever it is connected in reverse bias, a small leakage current flows through the diode. As the reverse voltage increases to the predetermined breakdown voltage, there will be a predetermined breakdown voltage for every Zener diode whichever is manufactured. It can be 6 volt, it can be 12 volt or so. So once that reverse voltage reaches to that voltage, applied voltage reaches to that voltage, then current starts flowing through the diode, whereas the voltage across the diode will remain constant. The current increases to maximum, after which it stabilizes and remains constant over a wide range of applied voltage. So this feature of Zener diode makes it very useful to be used as voltage regulator. Then if you see the characteristics of a diode here, so here again, when the anode is made positive with respect to cathode, it is same like your conventional diode forward bias. In reverse bias, it will go to a point Vz, that is the Zener breakdown voltage. That is where you're having your constant voltage, and then you have a sharp breakdown here. There is a sharp breakdown here. This is a sharp breakdown, which is called as Zener breakdown. So that means voltage will remain constant and the current will increase. This feature is very important. Voltage will remain constant and the current will increase. Okay, in that voltage you can increase or decrease the current as your application is, but the voltage will remain constant. And here I have shown you the symbol whatever I have shown you earlier, and this is also will be another type of symbol in which you can represent a Zener diode. Okay, this again our characteristics will be studying. This again our characteristics will be studying when we study the semiconductor or devices in detail. Okay, then we'll see what are the important applications of Zener diode. Number one is voltage regulator or stabilizer. As I've told you, it can keep the voltage at a particular constant value specified by the manufacturer, and in that at that value you can increase or decrease the current. So that is a feature by which you can use it as a voltage regulator or stabilizer. It can be used for meter protector. Okay, it can be used for a wave shaper. Clear? Then we'll go to see what are bipolar junction transistor, which is called as BJT. Now, bipolar junction transistor is a three-terminal semiconductor device that consists of two PN junctions. Okay, two PN junctions means, say, either you can have P, N, P, or you can have N, P, N. Okay. So either you can have PNP, where a N type of semiconductor is sandwiched between two P type, or you can have a NPN, where P type semiconductor is sandwiched between two N type semiconductors. And it will be having three terminals. The first terminal will be called as emitter, the second will be called as base, and the third one will be called as collector. Same for NPN also. The first one will be called as emitter, second one will be called as base, and the third one will be called as collector. Okay, so these are very important things what you should know. And then it is a current control device. Current control device because the input current will manage or can handle the output voltage. So it is called as current control device. Okay. Then we'll go to see what are types of bipolar junction transistor. There are two types. One is PNP BJT and one is NPN BJT, as I've shown you earlier. One is PNP and one is NPN. So what is this PNP BJT? So as I've told you, in that N-type semiconductor will be sandwiched between two P-type semiconductors. So here if you see the definition, in PNP BJT, the N-type semiconductor, N-type, that is here, whatever you're showing here, this is N-type semiconductor. Okay, this is N-type semiconductor. It is sandwiched between two P-type semiconductors. These are your P-type semiconductors. This is P and this is P. Okay. The two P-type semiconductors act as emitter and collector. So this is acting as emitter and this P is acting as collector. This is going to emit the charge carriers. This is going to collect the charge carriers. That you will understand once we go to the semiconductor theory. And then in between you are having your N type of semiconductor which acts as a base. Okay, so this is your emitter terminal, this is your collector terminal, this is your base terminal. This is the junction between emitter and base, this junction, and this is the junction between base and collector, that is this junction. So it is a two junction, three layer, three terminal device. So it is having three layers, three semiconductor layers it is having, and it is having two junctions, and it is having three terminals. So a BJT will have three semiconductor layers, PNP or NPN. Then it will be having three terminals, emitter, base, and a collector. And it will be having two junctions, junction 1 and junction 2. The first junction is between emitter and base, and the second junction is between base and collector. Same thing with NPN transistor. Only thing here, what will happen is P-type semiconductor is sandwiched between two N-type semiconductor. The two N-type semiconductor will act as emitter and collector. So here also you can see this N-type is acting as emitter and this N-type is acting as collector. So in between you have P-type semiconductor which will act as base, and the terminal which is connected to emitter is E, mentioned as E, that is the emitter terminal. This will be collector terminal, and the center one will be the base terminal. The first junction between emitter and base will be called as the first junction, JE, and the second junction between base and collector will be called as JC. So again here you are having three terminal, three layer, two junction device. Only thing here the arrangement will be your P-type semiconductor is sandwiched between two N-type semiconductors. Then how do the symbol look like? How from the symbol you can understand whether it is NP or NPN or PNP. So the very important thing in symbol is you have to concentrate on the emitter terminal. You have to concentrate on the emitter terminal. Now, if it is PNP, then the arrow shown here will go inside. That is the flow of a conventional current is going inside from emitter to base. Okay, the flow of a positive or the a conventional current. Similarly, if you have NPN, as I've shown here, this is NPN symbol. In NPN, you can see at the emitter, you have to concentrate at emitter only. The arrow is shown outside. This arrow is shown outside. This is the main difference which will tell you which symbol is for PNP and which symbol is for NPN. So the arrow of the conventional current, if it is going inside towards the base, then it is PNP transistor. If it is going outside at the emitter, then it is NPN transistor. This is a very important difference which you should know, and you can differentiate the symbol of PNP and NPN only by observing the arrow which is marked at the emitter terminal of the symbol. Okay, the center terminal will be called as base and the other terminal will be called as collector. So this is how your symbol of PNP and NPN or transistor will be shown. Then if you go to see packages of BJT, there are many packages available in market. There are many ways by which a transistor can be produced. But the important thing will be its three terminals, that is which terminal is emitter, which terminal is base, and which terminal is collector. That you should identify according to the manufacturer's manual. And then only you can understand how to connect that in your circuit, because you should know which is emitter, which is base, and which is collector. Then we'll see applications of BJT. So there are many applications, but as a few we can say it can be used as an amplifier. Amplifier is a circuit which will increase the strength of a weak signal to strong. Then second one, it can be used as an oscillator. Oscillator is a circuit which can produce repetitive waveforms. Third one, it can be used as a demodulator, where from a modulated carrier you can extract the information, that is called as demodulation, that you will be studying in our communication circuits. And fourth one, it is used as a switch. It can become on and off depending upon what power supply you're applying at the base of the transistor, you can make the transistor on and you can make the transistor off. So it can act as a switch. So these are a few applications of BJT. Thank you, students.